In this example, we will learn about the simple concept of Bayes theorem, not mathematically. We will see this concept in geometrical point of view, and we will try to understand what is the real meaning, why it is the so most important theorem in the probability theory. And in my knowledge, if we like, it is my most if we just value some theorem in probability theory, I just love most the important theorem in my knowledge. This is the most important theorem in probability. Okay, but the main concept is this is the simple and very elegant beautiful theorem. Okay, and very useful. Just we see in some if you just when you are discuss some example of a real world example when we are discussing, then we just see how useful and how beautiful this one. Well, this one simple, if we just write this is one a simple, elegant, as well it is a beautiful theorem. Is beautiful. Okay, simple total classification theorem, naive Bayes, that we call naive Bayes. Totally this one is dependent on this Bayes theorem. So because of this, we are calling this classification theorem naive Bayes classification theorem, only because of this. Okay, because of this logic we call the naive Bayes classifier. So from this name you can see how important this theorem, how important this one, because only for this theorem and we build a simple a classification technique. Okay, then we see how beautiful and how simple this one we see. Sorry, this one will be Bayes, naive Bayes. Because from this name Bayes theorem we call naive Bayes classification. So first going to discussing the geometrical point of view and some example. So first see the mathematics of this theorem. Just see the mathematical. Okay, so what is the mathematics of it? So simple, just write down probability. We see that probability of A is given B, that is probability of A. This is the condition probability. And what we see these definitions of this probability. So the definition simple of, so the simple the Bayes theorem, we will prove this theorem. Just first write down the statement, what is saying of this probability of A, B given A, probability of A divided by probability of B. This is the conditions if probability of B is not is equals to 0. This is the simple statement of, just see the mathematical term first, then we will discuss its meaning, real world meaning and geometrical interpretation of this. So let's prove. So before going to the proofs, first we have to know some terminology of the. In old days, when our computational power is not popular and when our computer is not occurred in the market, then the statistician, the mathematicians are using this term to calculation some, to predict something. Okay, so first right. So this term are called the posterior term. Posterior term. This term is called the prior term. This term, actually this conditional term, actually called the likelihood term. And this term is called the evidence term. Okay, so if you're not interested, if you just forget it, but the main thing is what is the meaning of this theorem. This is the main thing. So this term are as usually used by statistician and mathematicians. So it is not important how you just remember this theorem. The main important thing is how you will understand the theorem, how will you understand the real meaning of this theorem. This is the most important thing. Okay, now we'll see this thing. So first going to the proof of this theorem. So first we have already known the definitions of the condition. So what will be the definitions of the conditional probability? This thing will be probability of A intersections B divided by probability of B. We have already known this thing. If our probability of B is not is equals to 0, we have seen this thing. And some authors, instead of writing probability of A intersection B, some authors or some books are writing this term. So don't be confused. Intersections and A comma B both are the same thing, just two different notations. B, or in set theory we simply know that probability of A, we simply know that probability of A intersections B is equals to P intersection of A. By simple set theory we know that, from simple set theory we know this thing. So now we can write this thing, probability of B intersections A divided by probability of B, or anotherly B intersection A. These are the both same thing, don't be confused. So I am writing the both the term, this one as well as this one, the both are the same thing. Now we are interested to find this one, probability of B section A. We know, we just see, if you just write the conditional definitions of this probability of B intersection A divided by probability of A, if probability of A not is equals to 0. Since this probability not is equals to 0, then we can easily multiply it from this side. Just we are going to multiply this probability on this side. So now what will be occur? Now our probability of B intersections A, we can write this one as it is from. Okay. Now we are simple just substitute this one on this formula, nothing else. Then easily we can prove out. So if you just write now probability of A with conditions B, now just simple put this one, that is I'm just putting this value, and under it will be probability of B. So this, if this condition, if our probability of B not is equals to 0, simple this is called the Bayes theorem. Simple this is, I think the proof you have simple by using the conditional probability definitions, we will easily prove this one. This is the 3 lines proof. Okay, simple, this one is called the Bayes theorem. Simple, this one is called the Bayes theorem. I think the proof of this theorem is not hard, easily you can prove it, but the main thing is that not proof, but the main thing is its interpretations and its beauty of the real world applications. This is the most important thing. So first discuss about the beauty and its, first let's take an example. So to discuss this example, now I am going to the Wikipedia page. Okay, just see the example from that. Okay, okay, so let's see. Oh, I'm just opening my pen. Okay, Okay, so here we have taken this example. So there in Wikipedia it is written it complicated, but if you see, this is not a simple complicated example. Just let's see this one. Just first let's see this example. So what this example actually saying? Actually they are saying that in a factory there have, I'm just using pen. What happened? So let's take this example. Let's discuss example. So what are they are telling actually in this example? So they are telling that in a factory there have only three machines, machine A, B and C. So just write down, in our one factory they have three machines. So for machines, let's call, we have three machines, machine 1, machine 2 and machine 3. We have only three machines, and which accounts for 20%, 30%, 50% of its output rate respectively. Means these three machines are given the output as 20%, 30% and 50%. Okay, I think clear. So just I am writing these output numbers. So just writing the what they are actually given. So they given the machines, the output is, so first machine output is 20%, means 0.2, 30% means 0.3 and 50% means 0.5. This machine is giving that output. And okay, and also they are given these machines of 5% are defective, 3% for machines B and 1% for machine C. So as you see the defective, or as well they are given the defective of these machines. I'm just using the another color. Show the defective. So if you see the defective means you can as use the misclassified point here. So if you see in data science point of view, data point of view means 3% are defective, means 3% are disclassified, misclassified. So in this example we are not using the misclassified concept, just in this example we are using the defective. Let's convert in probability. So 5% defective means what? So the defective now will be 0.05 for machine 1. So defective for the machine 2 means 3% means 0.03, and for machine 3 it is 1% means 0.01. Okay, simple. This is the output of this machine and this is the defective of the machine. Okay, so now they are calling that if a randomly selected item is defective, if we are just pick a item, means this only these three machines are produce the item. Okay, if from this item, if we choose a item and if this one is defective, then what will be the probability that this product is produced from machine C? So just first understand the English term concept, then we are just rewrite this thing in mathematically. So first actually they seen that in a factory, they have a factory in a town simply, and in that factory only they have three machines. So first the data given that the first machines given the output 20%, second machines given the output 30%, and the third machine given the output 50%. Okay, and on that items the first machines also given some defect product, that is 5%, similarly for 3% for machines B and 1% for machine C as well. Okay, now the given their requirement is, now if they are choosing a product and it is just, if they found it is defective, then now they are interested how, what is the probability that this product is coming from machine C. Okay, so just draw this one. This is the total pool. If you just see the pool of total items, that is the items, if make from machine 1 it's come and food here, make from come machine 2 come and food here, as well it is product come and food here. Just the product, those are built from our machines, these three machines, and come and food this pool. Okay, this is the total output of our factory. This is the total output of our factory. And let's take we are randomly choosing a product from our Okay, just randomly choosing a product, and if this product, if we find this product, it is a defective product. If we find this is a defective product, now the requirement is, what is the probability this product is coming from machine 3? Okay, this is the main thing. This is the, if this product we found that it is defective, then what will be the probability that this machine is coming from machine 3? So let's see step by step. So first we have to choose the total output, total item. Okay, first let's choose the event. First let's take this is the event. So first we choose, first we consider I event, that is B. Okay, so this event will be that item we have choose, it is defective. So let's call this event, this thing, the item we have chosen randomly, this is coming is defective. So let's call this this thing is our event B. So our event will be item that we will choose is defective. So let's take this is our event, and we call this event as event B. Now the thing is, so this defective item is coming from where? Machine 1 as well as machine 2 as well as machine 3. When this product will be defective, means if our defective product coming from machine 1, if or it is coming from machine 2 or it is coming from machine 3. So the probability of item, so the probability of this our defective item, of any item from this pool, if we choose the item and it will be defective, means this item is coming from machine 1 or machine 2 or machine 3. This means what? This means if we just find the probability of these defective items, then we have to find the probability of the defective item which is coming from machine 1. Okay, means our A1, just see this thing here, just see this thing. If XA that is taken here, XA, this XA means what? This XA means this item, our item is coming from this. XA means what? Actually just see this thing, see this thing, this XA here, XA means our machine A means here machine it is A, here machine it is B, here it is C. Actually machine A produced item means machine say output, if you call machine say output. This means what? Machine B output. And this thing means what? Y. Just see the Y term. Y means they have taken here, Y means Y denoted the event that is randomly chosen and defective. Means actually instead of B here, they are chosen over random B. I'm using the same terminology here. I'm here using the item is defective. I'm choosing this one. Just over it. Okay, now this term means what? Just see this term. This term means what? Actually the item is defective and coming from item. Y means what? Y is item is defective, and Y item is defective. The condition is what? Condition is it is coming from our machines A, that is 0.5. So it is the, just write this thing in language, defective item coming from machine A. Okay, similarly defective item coming from, so just put down the probability in this case. Yeah, okay, now we are interested to find the probability effective probability of these defective items. So probability of these defective items means the probability of defective item is defective as well as it is coming from machine A. item is our defective and it is coming from our machine A, or item is defective as well as it's coming from machine B. So there will be three possibility only. Item will be defective only for three possibility. If it is coming from machine A, or it is coming from machine B, or it is coming from machine C. Only there are three possibility. So just I am writing this thing in language. Plus sign means or, and intersection means and. So or. So just for using or sign, I am using the plus sign. So now here I am just applying the conditional probability. Just you already see the what is the definitions of conditional probability. Probability of A I B means probability of A intersection B by probability of B. I'm just multiplying this thing both sides. This means what? Probability of this sign means probability of Y intersect Y. This means probability our product is defective and it is coming from machines A with probability of machine A. What is this? Just I am just putting this thing in here, nothing else. Okay. Similarly from here, probability of product is defective and is coming from machine B into probability of machine B. How much probability is? Probability of our product is defective and it is coming from machine C. Just same thing. Just I am using the definitions of the conditional probability, nothing else. And as value already we have known. What will be the value of probability Y divided by this one into probability? Just I am using the multiplication. Just put just simple. If you just put this value, then easily we can get this one. Okay, just this one. So this thing means what? Just see this one. This is probability of D. That is the whole that is our total whole pool. In whole pool, that is our whole product. So overall whole the product, our probability of the item will be defective is 2.4. This means what? Simple, this thing means 2.4% of all the product are defective. This means that actually in whole if our product is here 100%, whole the product, then only 2.4% means defective product. If this one defective product, black portions, so this portions is actually 2.4%. So of all the product only we have 2.4%, and from the how we get this 2.4%? Because of only from our we are using the if our product coming from machines A, or it is product coming from machines C, or it is product coming from machines A or B or C. Just I am using the or plus sign, just in conditional probability concept here, and I have just simply counted the defective product overall whole the product, how much product are defective. Now just here using the to actually what we have to find, we have to find that the product is defective. Already we have given this product is defective. Just we have using the another color to find the defective product. Just see the green one. Okay, I will not using it. Just see the green one. Actually this is our green color we are denoting here for our requirement. Actually our requirement is we have already find a product, defective product, that is product B. Sorry, product Y. Actually product Y we have taken here product Y. Actually we have already a defective product, and now interested to find it is coming from machine C. Okay, now we are just interested to find that it is coming from our machine C. So now what will be the probability? Just simple, here we are applying the Bayes theorem. So what Bayes theorem says? Bayes theorem says that here probability of, actually what we know, y divided by mc. Just see the beauty of the Bayes theorem. Probability of y into probability of mc. This one actually Bayes theorem says, this Bayes theorem, this is the simple definitions of the Bayes theorem. Okay, nothing else. Probability of y by mc, and age value already we have known. Just see this thing here. Age value, probability of xc, means here actually they are taken the xc for machine c. xc divided by probability of y. Just I am writing this thing, just same thing is written here. And age value already we have known, and this value is coming from here. This value already know, that is our product is defective and it is coming from machine c, and how the product machine c are produced already know, and this is means how total defective product, value of the total defective. So the final value will be 5 by 24. So now see the beauty of the, it is simple and elegant theorem. The most thing is the beauty. Just see the real world. How can easily we can find? How can easily find this complicated thing? How? So this is the main beauty of this. So if you are interested, there are many example. How much you just constructed English language to a mathematical. This is the simple beauty of mathematics. So this is the main art of the mathematicians. How a real world problem you just first how you understand the real world problem, how you convert it to a mathematical. We have many mathematical tools. The main thing is that how you observe this as real world problem and how to convert this real thing in mathematics. This is the best beauty. I think the Bayes theorem concept and its importance and its simplifications prove everything you are clear. And if you are interested to do some more problem, please Google search it. Simply the exercise on Bayes theorem, just simple search here, you can easily find it. Many of the problem available. Okay, now we'll see in next class.